Hello everyone. Good morning, good evening, good night, good afternoon, wherever you are. We are covering the Irodov. This is 3.147 electromagnetism. We are solving the problems for electric current. I'm not going to repeat the question. I hope you are familiar with the question. So this question basically says there is a long cylinder extending from infinity to infinity. Okay, and it is a very long that is what we have to that is what the intuition that we should have. Now we have the radius a equals to 1 centimeters, and we have the electric field that is 0.9 kilovolts per centimeters. So and we have the velocity in which this is moving, and this is what is that, and we have the velocity 10 meters per second. So let us write the data that we have. We have the radius in SI units, 10 power minus 2 meter. We have the electric field that is 0.9 into, this is 10 power 3, the 10 power minus 2 goes 10 power 2, so 10 power 5 volts per meters, and velocity is 10 meters per second, right? Okay, now I have to find the current. So first write what you have to find out. Now what is the formula for current that I do know? It is Q divided by T. So I need to find the Q, I need to find the T, in which the time I need to find the Q and the time in which that Q passes. Okay? So I have to use the variables given in this question. The variable is electric field. So I have to express the electric field in the terms of known things. So I know the value of electric field in the periphery of a cylinder. It is given by E equals to lambda divided by 2 pi r epsilon naught. Quite an easy derivation using the Gauss law, right? And what is the value of Q? Q is let's say a dx section will pass in dt time, then the value of Q will be lambda dx divided by dt, isn't it? Right. Okay, now so I can write as lambda v. So I need to find the lambda, okay, and then I'm done. So what is the value of electric field? What is the value of lambda from that? Lambda equals to 2 pi a epsilon naught electric field, right? Okay, so now if I plug in the value of current will be lambda. What is the value of lambda? 2 pi a epsilon naught and electric field times the velocity. So if I plug in the values, then the value will come out to be 0.5 microamperes. All right, so you can do it yourself. 0.5 microamperes. I hope the concept is delivered to you, and it is quite basic question. Now what we are going to do special in this series is I'm not only going to solve the question, I'm going to give some other questions, one or two questions related to that very topic, tougher than this, right? Okay, so the question for today for this problem is, I have an electric cell, okay, and the radius of the cell is, there is a sphere, okay, metallic sphere I should say, metallic sphere, and I have this metallic sphere, and then it is earthed, okay, it is earthed, and on the axis of this there is a charge Q moving in, okay, with a velocity v, and at a and the distance is supposed to be r. Okay, now I have to find the current in this earthing wire. So you have to find the electric current. Find the electric current in the cell when the charge is at a distance r naught. So please try it yourself, and I will